All right. Beautiful evening, beautiful people. This is a very important class. So thank you guys for joining. Thank you guys for joining. I can see you there. I can see you guys there. Okay. We have quite a number of people online already. Good evening, everybody. Hope you enjoyed your weekend. Okay. Yeah, so this is quite a very important class. In our last class, we went into normal distribution, which is one of the density functions we're going to be talking about. And I gave you guys a very great introduction to normal distribution. And we ended the class with ensuring that everyone in attendance is able to standardize a normal distribution. And I explained to you guys the importance of standardization. Now, just a quick revision on normal distribution, because today we want to go into lots of applications of normal distribution, and we'll be dealing with several examples, real life examples. And also at the end of this class, before the end of this class, I would love to give you guys a very important application of normal distribution, and that will be applying normal distribution to binomial distribution. You're going to be seeing how to go about that in this class. But quickly, guys, when we were talking in our last class, I told you guys that the first thing you need to know about normal distribution is that it's a symmetric distribution. Meaning of symmetric means that the distribution will be divided into two equal halves. When you divide this distribution into two equal halves, the midpoint is going to be. I told you that one of the properties of a symmetric distribution is that the midpoint will represent the mean, represent the median, will also represent the mode. So one of the things you need to know about a symmetric curve is that the mean, median, and mode are all equal. All right. Now, I then went on to talk about one of the way to identify the parameter of a normal distribution, and I said we say X is normally distributed with a mean and standard deviation sigma, with a mean mu and standard deviation sigma. All right. And then if you guys could recollect, I told you guys that this is very nice, but one problem that arises from this is that we cannot have several tables that we'll be able to use to deal with all the different possible models under normal distribution. Now, I told you that normal distribution, one of the reason why we have a widespread application is that it's one of the most important distribution because it models many of the real life experiences. That's this distribution we're talking about, normal distribution. It's very realistic. It deals with so many day-to-day applications, and that's why you're going to be seeing some of the questions we're going to be solving, and you're going to see how we're going to be modeling several experiences using the normal distribution. All right, but I told you guys that take for instance we have a question that said I believe we solved a couple of questions. Let's say we had the mean of a scenario mean equals to 10.5 and the standard deviation was 3.5, for instance. Now, if you're going to be able to solve this question under normal distribution, you'll be needing to have a table that obviously as the mean being 10.5 and the standard deviation being 3.5. Now, after you're done with that, if you then need to solve another question of which we have maybe the mean now to be 20 and the standard deviation to be 1.5, for instance, that means in this case now we would need to also get a different table to also deal with this particular question. Now, this is not actually feasible, and that's the reason why we have to do something we call standardization, where we're going to be converting our normal distribution to what we call a standard normal distribution. All right. And in that case, I told you that what you need to know about a standard normal distribution is that a standard normal distribution, unlike this one, where we say X mirrors this, a standard normal distribution has a peculiarity in the sense that, first of all, we don't talk about X there, we talk about Z. So we'll say Z follows a normal distribution, but in this case, the mean is always 0, the standard deviation is always 1. So this is a standard normal distribution. Don't forget, it's still a normal distribution, but it's a standard normal distribution with a peculiar characteristics, having a mean of 0 and a standard deviation of 1. So one of the biggest things you have to do when dealing with normal distribution is that you want to find a way to always convert every question you have to a standard normal scenario, which the process of doing that is what we call standardization. So we say you should standardize. So bringing a normal distribution to a standard normal distribution is what we call standardization. All right. And I told you guys that it's a very simple process. A very simple process in the sense that all you need to do is for you to bring this to this, you just have to go on to make sure that if you want to turn X to Z, you go on to subtract the mean and divide by sigma. This is all you have to do. So Z is obviously equals to this. This is Z. So for you to get Z value, to get your Z value, you had your X values before. Majorly, all your questions are majorly going to be given with X values. That's the normal distribution. But for you to convert that to the Z value to a standard normal distribution, what you have to do is to take that value that was given to you originally, subtract the mean from it, and divide by sigma. That's by the standard deviation. And that process, the process of doing that, subtracting the mean and dividing by standard deviation, is what we call standardization. So that's all you just need to do. This is how simple it is. Whatever you're dealing with under the normal distribution, go on, subtract the mean, divide by standard deviation. That alone, doing that alone, you are good to go. You've been able to standardize that normal distribution. Now, these are all the things we dealt with in our last class, and I'm sure you guys really understood it, and I'm sure you have done a lot of practice. Now, in today's class, we want to get into the use of tables. That's the first thing we want to get into. Then we go on to see real life application, and then, as I said already, we'll then find a way to touch the application of normal distribution to binomial distribution. You'll be seeing it's a very important thing you need to learn, and it's a very examinable question. So you guys will see the importance of knowing how to use normal distribution to solve binomial distribution. There are certain cases in binomial distribution where it's almost impossible to solve. So in that case, applying a normal distribution will come in very handy. So I need to teach you guys the way to do that. All right. So without wasting time, let's get right into it. So you guys, you need to turn to your table. I'm going to be explaining the peculiarity of the table you have with you. I'm sure you guys should have seen two different tables being sent to you. So you have two different tables with you. That's what we call the Z table. All right. So you can turn quickly to the Z table that you have with you, and you would see two different tables with you. And I'm going to be showing you the picture you will have on both of them. All right. So you would see something written like this. You have zero. You have zero being written here. And then you would see that this other one too has zero. All right. Then you would see something like this here. And then you see something like this here. So this is how the two tables with you look like. When you see this part being shaded, I'm going to explain to you how to make use of these tables in solving questions on normal distribution. So you should have these two tables with you. The first table has a small part to the left shaded, whereas you have the other table that has a larger part shaded. All right. One thing that we have not yet written is you would see the rows Z here, the rows Z here, and the rows Z here. So you see this on these diagrams on each of the tables you have. Now, it's always good practice to be able to solve these things even without seeing all those diagrams. But of course, the diagrams are a very great direction for using your tables. But at the end of this class, you should be able to solve your questions even without these diagrams on tables. So by the end of this class, you should be able to understand it so well that even without you having the diagrams, you know exactly how to use them, because in your exam, I'm not sure you will be seeing these diagrams on any of your tables. All right. And it's very simple. Now, let's get right into it. I'm sure you guys are really attentive at this moment. This is very key. Now, if you look at this table that has the smaller shading, you would notice that this is how you're going to see, this is one of the things you're going to see on both tables. You're going to see a column. Let me take this off. So you would see a column Z, and then you would see on the top of this column, you would see 0.00. You would also see 0.01. You would also see 0.02, and so on and so forth. 0.03, 0.04, and I believe it got to 0.09. You will see something like this, right? Now, this row with 0.01, 0.02, 0.03, 0.04, you can see it's common to both tables. Both tables have exactly these things. But one thing you're going to notice that is different with both tables is that of this smaller shaded part, you'll be seeing negative values on this side. You would see it started from the table you are holding. Of course, this is just a limited version. You could have other bigger table, but you have minus 3.4, you have minus 3.3, up until it got to, you had minus 0.1, then you had 0.0. All right, this is for this smaller one, this smaller shaded one. You would see it started from minus 3.4, it ended at minus 0.1 and 0.0. All right. Now, this table obviously identifies with negative Z value. All right. That's what you need to know. This table identifies with negative Z values. As you can see, the values in this particular column, this first column is all negative, minus 3.4, minus 3.3, on and on and on until you got to, it kept on reducing by 0.1 up until it got to minus 0.1. You're going to see that very clearly. Now, let's get right into it now. You see, every value you see within this space, every value you see within this space, all values here, all the values you see here, you can see several values there. You can see you have that for under 0.00, under 0.01, and on and on. You can see several values here. Those values are the values that represent the area under the curve that you are dealing with. We're going to get into it very soon. So all these values here represent the area under the curve. This is the answers you majorly will be looking for. These answers here. So they represent the probability. You know, I'm sure you guys, if you followed the last video, you understand that when you're dealing with, I told you guys already that when the question says, because we solved some questions in our last class, the question will say, find the probability of x greater than maybe 39.5, for instance. You went on to standardize, then you saw probability of, you turned it probability of z greater than maybe 3.2, for instance. For instance, this was what you probably resulted to when you were done with standardization. After you were done with this, you got 3.2. They said, of course, look at what the question was actually to find. Find the probability that z was greater than 3.2. Your probability, when you're trying to find probability, I told you guys already, you're finding area under the curve. If you remember when I explained all these things, we did it under continuous random variable. I told you guys that the area under the curve for the whole curve. Let me see if I can get that from the comment section. What's going to be the total area under the curve from the least limit to the maximum limit? What's going to be the total area under the curve? Can anybody give me the answer in the comment section quickly? What's the area under the curve, guys? Okay, thank you very much. Now, you understand? In another way, I can ask that question in a different way. I can say, let's assume the entire limit from beginning of the whole function, let's say it was a to b. Let's say the minimum limit is a, the maximum limit is b. Guys, what's going to be, let me say it this way. What will I say is the probability that x is between a and b? For a question like this, if I say what's probability that x is between a and b, what's going to be the answer? Can anybody give me the answer? What's going to be the probability that x is between a and b? Of course, it's the same thing I just said earlier when I said the total area on the curve, because the probability of x being between a and b, since a represented, that's in the case where a represented the lowest limit and b represented the highest limit, that means the whole function is bounded by that set of limits we have presented. If it represented the total of everything, that means it's everything. Nothing is outside, is after a, nothing is before a, nothing is after b. In that case, the probability of x being between that will be 1, because the probability of, I told you guys already, it's more like saying the probability of the sample space, probability that it's going to be 1. So you need to understand the relation between using the word probability and using area under the curve. Now, in this same way, guys, I also told you in the last this thing that if I wanted, let's say this was C, and let's say this was D, this space now was C and this was D. Let's see, if just imagine you tracing this up now. If I change the question now and said, what's the probability of x being between C and D? All right, that means now it's not everything now. That means I'm saying, what's the probability that x is between C and D? Now, in a nutshell, one other way I could say that is just saying, what's the area under the curve between that space? That means this space, I don't want to put this red marker in there, but if you can understand, this space bounded by C and D, the area in between that place is what exactly I'm asking you to find in that question. You guys need to understand the relation between using the word probability and using the word area under the curve. So if I say what's probability between C and D, all I'm asking you to find is what's the area under that curve. And now the table, back to our table. The table, as I said, all these values here represent area under the curve. They represent area under the curve. All this place, you would understand the usage now very soon. At the end of this class, you will know how to use this table very well. It's very simple. So this whole thing you are seeing here represents the area under the curve. Note that. And also, I can also say they represent probabilities, because I already told you there's a relation between saying area under the curve and probability, as I just showed in some few minutes back. So all these things here, they are all probabilities, or you can say they are area under the curve. Good. Now, as I was saying, I was talking about this first smaller, this curve with a smaller shading. I told you that this is always a negative table. You can see this as the one that identifies this is a negative Z table. So you can see that all the values there are negative and negative Z values. You can see that. Now, if you turn quickly to the other one, this other one now, you will notice in that case that you have positive values. If you turn to the curve quickly, you will see it started from, this other one started from this other curve, this one now with a larger shading. It started from 0.0, went on to 0.1, then it went on and stopped at 3.4. You should be able to see that in the table I sent to you. So you can see that we have positive values. So obviously, you know, this is the positive Z value, all right? Positive Z value. Now, and all the values here within it also, you can see it has values inside this space here. All those values are all area under the curve, and you can say in a different way, they are all probabilities, all right? Probabilities. Now, good. Let me now explain to you how to read this table. If you have understood what I just said now, let's get into knowing how to read this table using read values with a curve given using these tables. Very, very simple. Now you can already understand the reason why we have these different tables. You can see the reason why we have this different table, because you can see that we're going to be having different values. So we're going to just, before we even start doing any real life application, I'm going to just use some quick examples to sharpen your understanding of this. So guys, please be very attentive and deal with your table. So let me give you a question. Now let's assume, I'm just going to assume. Now let me quickly say something. I'm sure everybody here understands number line. You can see right here, we said this was 0. Then we were saying whatever the Z value is. This represented that whatever your Z value is. Now, if this was 0, and let's see, depending on what you're dealing with, let's say this was 1, let's say this was 2, let's say this was 3, let's say this was -1, -2, -3. Let's just say it that way, all right? Now, obviously, you can see clearly that if I have a question and the question is less than 0, let's say we're dealing with let's say -0.2, -0.2. Of course, you know that, let's say our Z value was minus, of course, you guys already we already did standardization. So let's just assume that you're dealing with a probability of, okay, now let me say something before I talk about -0.2. You recollect that when you were trying to solve your standardization, you had different set of questions. You had examples where you would get, I'm assuming you are done standardizing at this point, you say Z greater than maybe 1.5. Possibly you said probability of Z less than -0. minus 0.7. Let me just put some random values. It's possible you got probability of Z greater than minus, let me say, yeah, minus 1.2. This is another good example. Let me also fix the one where you had different, maybe minus, let's say minus 0.8 and let's say 3.2. Let's just look at these different examples and let's see how we're going to handle each and every one of them. These are all possibilities, all right? These are all different possibilities where you have probability of Z greater than 1.5. You can see that's going. Let me try and draw the diagrams for you. Let me first teach you guys to draw the diagrams properly. So let's say I'm dealing with probability of Z greater than 1.5. Now, you need to know that it's always very good. It's good practice to always know how to sketch the diagram. And sketching the diagram is very simple. So look at it now. You understand your number line. This is 0. Of course, everything above 0 in front of 0 are all positive values, and the one below at the back of 0 are all negative values. So when I say Z is greater than 1.5, obviously you know that, imagine I'm using this scale, you may have a different scale. We're not going to have the same scale when drawing. Some of you's diagram will be bigger. Sometimes you don't need to be exact. So you don't need to be exact. What I mean by that is somebody may draw something like this, and this may be how he identifies his own. Someone else may draw the same thing and identifies it a bit bigger. In the end, of course, if you can be as cool as possible, but in the end, what matters is you knew the interpretation. It's still signifying the same thing, but you were just a bit not very precise. Maybe you were using a different skill. So just understand how to do. You're going to see how easy it is. So I'm dealing with, say, probability of Z greater than 1.5 now. I want to draw a diagram for it. Let's say I have this. Of course, that's simple to do. You just have to draw a symmetric curve quickly. You obviously know this place is 0. All right, you know that spot is 0. You know this spot is 0, obviously. So what you want to do next is to look at the question you are dealing with. Greater than, number one. Greater than. I'm sure you understand. Greater than is always, if I said 1.5, first of all, identify 1.5. If I'm dealing with 0 here, probably 1.5 will be around here. Probably. You see, I'm not going to try to be, I don't want to be putting a lot of ruler and saying this is no. Let me just assume this place is 1.5. I'm just going to guess. Like, it's not compulsory you are too exact. That's what I'm trying to say here. So this is 1.5. So I want to draw the line here. I want to draw my line to say this is 1.5. So this is 1.5 now, right? This is 1.5. This identifies with 1.5. Let me try and get a different marker. So let's say this is 1.5. All right. Now, of course, this is no-brainer. You guys can easily deal with this because if this is 0, this could be 1.5. Somebody else may put this 1.5 here. That doesn't mean anything, depending on whatever you are scaling in your mind. Now, the other thing to look at is the sign, the inequality sign. So you can see this is a greater than. So my interest here is the region greater than. So this is 1.5. This is 1.5, right? I'm interested in the greater portion, the side greater than. So what I'm going to be shading is going to be, of course, you identify with this. This is greater than. So you can see I've shown greater than. All right. Now, if this was less than here, let's say this inequality sign was less than, I'll be shading this portion in that case. That's one of the important skills you need to know. So let's try and do for the next one. Look at this one now. Less than minus 0.7. Okay, good. Let's use this one that even has a good scale. All right. Minus 0.7. Maybe you're going to put 0. Of course, if this is minus 1, 0.7 will be somewhere here. So let's try and trace that one up. So I'm sure you understand that this could be I'm not, it's not bad for me to identify this place with minus 0.7. Of course, this is 0, this is minus 1, so this should be minus 0.7. I'm sure nobody disagrees with that. Now, we go on to then look at the sign. The sign said less than minus 0.7, less than in this case, not greater than, less than. So, of course, I'm sure you identify with this portion. This is the portion that is less than. This is less than. That is less than. If they said greater than here, this was greater than, then you'll be shading this other portion. So simple and straightforward. You don't need to worry too much about anything here. Now, let's look at the other one. Look at the other one we're dealing with here. We're dealing with minus 1.2. So, of course, you know that this is going to be your 0, right? The midpoint is always a 0. Then we're dealing with minus 1.2. So I'm just going to try and use this kind of scale. This is if this is minus 1, then 1.2 should be around here. I'm sure again, I told you, people may have different scales of how they, depending on whatever they decide to use. But I'm going to call this place minus 1.2. So I'm going to say this is minus 1.2. All right. So that's minus 1.2. Then I'm sure I can raise that up here. You can see, just that simple. That's minus 1.2. Now, I then go back to my sign. This is minus 1.2, right? What is the sign here? This is greater than. This said greater than. So obviously, I'm shading. This is the greater than. This is the side. This is the area that is greater than minus 1.2. You can see how beautiful this is. And let me try and look at this other one. I need me to do this here. So you need to look at this one now. This is the one that looks, you probably want to pick standard normal. This is obviously for a guys, let me quickly explain something to you quickly. Can anybody in the chat box tell me why I have the midpoint as 0 for this particular case? Before I'm trying to answer this question, I want to quickly resolve so you guys don't misunderstand why this place is always 0. Can anybody here tell me why this is 0? Why do we have this midpoint, the mid of the distribution? Why do we put 0 there? Anybody? Can anybody give me a reasonable answer to that? Why I'm always writing 0 here, 0 here, 0 here? It's not magic. It's not. It's very. It's part of the whole thing. Is there anybody there that know the reason why that place is 0? Of course, let me quickly give the response. It's very simple. I told you guys that a normal division is symmetric about the mean. A normal division is symmetric about the mean. That was standard. A normal division is symmetric about the mean. But don't forget, we're dealing now with a standard. You can see I'm dealing with Z, Z, Z. And I told you guys already that Z represents a standard normal distribution. And I told you guys that Z is a special type of normal distribution with a mean of 0 and a standard deviation of 1. All right. So, and as I told you guys already that this is a standard normal distribution. And I told you guys that symmetric distribution is always symmetric. We said normal distribution is always symmetric about the mean. So in the case where we're dealing with a Z distribution, a Z curve, we're dealing with the mean of 0. Because I told you guys that standard deviation, sorry, the standard normal curve has a mean of 0 and a standard deviation of 1. And that's why you see that when we want to make the scale, we want to put in 1, 2, 3, and thereabout. So it's the major thing you need to note is that the midpoint will always be 0 because it's a standard normal curve, the standard normal distribution. All right, that's very simple. That's very simple. Good. Now look at, we have 0 here. Obviously, we're trying to identify with this. Now, if you look at what we have here, let's just try to. Of course, I don't want you guys to spend so much of your time trying to always scale right. You just need to be able to guess and just intuitively do these things. You don't need to be very exact. So I'm not trying to put a ruler to it. So 3.2, I'm going to say 3.2 is somewhere here. That's what I'm going to say. 3.2, positive 3.2 is obviously going to be somewhere here. And negative 0.8, this is 0. So negative 0.8 should be somewhere here. So negative 0.8. I'm sure nobody should argue with me. I may not be so exact. That may not be exactly how you scaled your own. But I believe a bit close to I'm a bit very close to, okay, minus 0.8. So if you look at what we have there, so I want to draw this line. That's the line for 0.8 and the line for 3.2. Now look at it. That's just based on what I have here. You know, this is 3.2, a bit farther from 0. Minus 0.8 is a bit closer to 0. So, and this is minus. So, you know, the minus is obviously on this side. So very simple. It's not difficult at all. So you want to now go on to identify where are you shading. Look at, we said Z is between minus 0.8 and 3.2. Look at the question. So it's greater than, you know, I'm sure you understand how to read inequalities. It's greater than minus 0.8. It's greater than, that's the meaning of this inequality. Minus 0.8 is less than Z. It means Z is greater than minus 0.8. So it's greater than minus 0.8. You would have shaded everywhere here. But they also brought in another condition and said it was less than 3.2. So obviously, the part of interest to shade will be the part between, you will not go beyond 3.2. You will not go beyond minus 0.8. So this is the shaded, the interest for shading. Guys, could you understand what we just did now? It's all about just being smart. There's no big deal around it. So let me give you guys something to do quickly, and I'm going to access your work. You're going to tell me if you got it or not. So let me just pick this question. So let's assume you're dealing with greater than minus 0.5. Let's assume you're dealing with greater than greater than 0.7. Let's assume you're dealing with less than minus 0.2. Let me assume you're dealing with minus 3.2 and minus 0.5. So can you guys draw this diagram? I'm going to give you my own response, and then you would obviously check it up to see if you're correct. So can you quickly draw those diagrams so you guys know exactly what we're doing here? So draw that very quickly so that you can correspond it to the diagrams I'm going to be drawing as the answer to what you have there. So draw that very quickly. Let me give you like just some few seconds more. Okay, I believe by now you should be done with the diagram. So let me give you the solution to it quickly. All right, so let's try and get the solution to what I just said. The very first one said Z is greater than minus 1.5. So you have minus 1.5. The first thing you want to identify is that this is going to be 0. All right. So minus 1.5, let's assume 1.5 minus 1.5 is A. I told you the guys, the interest is not in being very accurate in your skill. So this is minus 1.5 here. I look at my inequality sign. I can see it's a greater than. So my shading will happen here. All right. That's just that about that. Let's see the next one. We have, of course, we want to first draw our symmetric curve. And we have 0.7. There's no negative here now. So 0.7 will obviously be a bit close to 0. Let's call this 0.7. All right. So that's 0.7. We are interested in the greater part. So I want to first identify with this 0.7. Then, of course, we're talking about greater than 0.7. So I'm interested in shading these parts that are greater, obviously. All right. And looking at the next one, we have minus 1.2. So if this is 0, then I want to have minus 1.2 should be, let me just put it here, minus 1.2. Right. Now, I identify that, of course, just draw my line like this. I'm interested in less than here. So obviously, I'll be shading this part. All right. And the last but not the least, we have there, let me try to manage this space. Okay, maybe I shouldn't manage this space. Let me just use, okay, so this is 0, obviously. Look at what we have here. We have minus 3.2, minus 0.5. So notice that both of them are both negative. So 3.2, I'm going to assume that should be around here. That's minus 3.2. Yeah. Minus 0.5 is obviously going to be a bit close to the minus, the 0, sorry. So let's call this minus 0. So we identify that here. We identify that here. So you can see that in this case now, the area I'm shading will obviously be just this part. That's how you just have to learn how to shade properly. It's very simple. There's no big deal about this. So this is one of the first skill sets you guys must have, because what you'll be doing using the normal distribution curve, the standard normal curve, the Z table, the Z curve, is you need to learn how to, first of all, identify the area of interest. So let's say you are done standardizing now and you got this value, Z greater than minus 1.5. The first thing you want to see is, okay, how do your curve, where's the area of interest? What are you looking for? Look at it right here. So that means I'm interested in all these areas, because I told you already, your Z curve deals with areas. All those solutions, all those figures we have within the Z table, they are all areas, or you can say they are all probabilities. The probability that Z is greater than 1.5, this is the area of interest, right? So guys, can you give me your feedback? How do you feel? Is it, are we going fine? Are you understanding what we're saying here? How to draw the curve? How many of you got the whole 4? Can I get the response to that? How many of you got the whole 4? You got the whole 4. You got everything. You were able to draw the diagram properly. How many persons there got the whole 4? Okay. Okay, that's good. That's nice. That's nice. I like that. So you got everything. That's good. How many of you got 3 out of 4? 3 out of 4. How many of you got 3 out of 4? How many of you got 2 out of 4? Okay, it's so simple. Yeah, I like that. Actually, I told you guys already, it's so simple. If you understand it well, it's so simple. So good. Now let's move on now. Let's see how we now deal with the table. All right. Now we have to now understand, as I told you guys already, understanding the kind of table you are dealing with. So if you see a table with this small shading like this, you're dealing with a negative table. Now this is, let me quickly say one thing. Even though I'm shading this small region, guys, I need you to know that as long as your value, this is 0 now, even though you see the diagram is looking more like it has to be a value, and no, that's not. This is just representing negative. So anything less than 0, as long as it comes less than 0, anything less than 0, anything that is occupying this region. This is the table you are using. That's your negative table. Anything, this one you're seeing right there, that looks like I say it must get here. No, that's not. You just, this is just for clarity. The meaning of this table, if you have 0 here, even if it was as small as this above 0, all right, if it's just as small as this, it's still a positive table. So if it's 0.1, it's still, you're still going to be using that table. Now, let's get right into the table now. Let's try and solve some few questions. Of course, before we get into real life application, let's even do some of the ones we just did. Let's say, for instance, we're dealing with probability of z greater than. Let's just solve some few questions. Let me start from the one that you guys will enjoy very well. Minus, let's say, minus 1.5. Let's do for probability of z less than minus 2.3. Let me do for probability of z less than minus 3.38. Let me also do for probability of z less than minus 2.14. Probability of z less than, let me do minus 0.25. So let's try and solve these 5 different questions very quickly. I may solve like 1 or 2. You guys may solve the rest. Now, this is just, of course, you can see, if you notice all these questions, it's one-sided. And there's a reason for that. I want to get you guys to build up on this. I don't want to disturb this in your mind. So you need to understand it thoroughly. Now, get into when you see when you see something like this. Now, one thing I'm sure of is, if you look at these diagrams, the first one now, minus 0.5. This is 0. Let's call this minus 1.5. I wrote this here. I'm interested in less than. So obviously, I'm shading this part. So you can see already how my diagram looks like. Good. You can see it exemplifies this first curve I talked about, the negative curve, the negative table. So guys, open your negative table. This is the table we'll be using in this case, because we're dealing with a negative value of z. So you're going to be using this table, all right? Not this other one. So you don't use this one in this case, because this is a negative z value. So go to your negative z table and let me tell you how to use this. Now, if you look at, as I said already, you started the z table with minus 3.4. Then minus 3.3, then it went on and on. It got to minus 0.1, then it got to 0.0. Good. Now, if you open that table now and check of course, I told you you're using this table now, the table that has the negative z values. For you to solve a question like z less than 1.5. Now, I want to say one thing quickly. Please pay attention. What I want to say next is very vital. This is key to understanding the use of the table. Every answer within this place, your table reads from left to right. Your table reads from left to right. That means, this is what it means. Every value you see inside here represents the area starting from the left to wherever you are getting to. Like in this case now, we're starting from the extreme left up until minus 1.5. So that is the area that if you check this table now, we'll check it right now, the value you get is the area from the extreme left up until that point. The same thing goes for this one. What I mean now is that, let me give you guys an instance. If you are told to find, let's say I will do for all these questions now, I will do the opposite of this question. I will do for greater than after we're done with this, but I want to expose you to this first. This table doesn't give you values here. So you cannot find this unshaded part now. You cannot find it using this table directly. All right? You cannot find it using this area that is not shaded now. Because imagine I was going to find probability of z greater than minus 1.5. I'm sure you knew that I would have shaded this area. If I was looking for probability of z greater than 1.5, If this was 1.5, this is where I would have shaded if it was greater than minus 1.5. I'm sure if this was minus 1.5, if I'm looking for probability of z greater than minus 1.5, this is where I would have shaded. Now I need you to know that none of your table will produce answer from right to left. Your tables produces area from left to right. So what you are going to do in a case like this, I'll be telling you in some few minutes. But now we are very cool in the sense that our value is there. We are looking for the area from left to right. You can see that the area I'm interested in is from left to right in this case. It's not from right to left. It's not this area I'm looking for. So any value I get now is still acceptable. I'm going to get the answer straight and direct. But in the case where I said if it was greater than, where you are shading this other side, if you go and check your table directly, you will not get the answer you will be getting will be answer from left to right, not from right to left. I'll tell you what you're going to do in that case very soon. But quickly, let's first solve this one. Minus 1.5. Minus 1.5. I did the shading because it's less than. I'm shading this part. Of course, you know the importance of shading now because you need to be able to recognize your area of interest. Your area of interest now is from the left to the right. The right part now that you are supposed to stop at is the point where you go to minus 1.5. Now, when you go to your table, for you to, don't forget, you can see the value that was written here was Z value. You can see on your table, there is a Z column. This is the Z column. This part is the Z column. That means for you to use this table now to find this probability or the area, anyone you want to say, you just need to go under your Z column and go and look for minus 1.5. All right. Now, guys, let me tell you how to read this table also. Minus 1.5 is the same thing as reading. You will be reading minus 1.5 under 0.00 because minus 1.5 is the same thing as minus 1.50. So you'll be reading, let's say minus 1.5 was here. You'll read the value of minus 1.5 under 0.00, which is the first column. You'll go and read the value that was given here. Now, if you wanted to find minus 1.51, let's say it was minus 1.51 we're dealing with, I will not be reading under 0.00, I'll be reading under 0.01 because minus 1.5 plus 0.01 will be minus 1.51. So if this is what I'm saying, if I'm dealing with minus 1.51, I will go on to read minus 1.5 under 0.01. All right, under 0.01. If I'm dealing with minus 1.5 alone, I'll be reading minus 1.5 under 0.00. So I'm dealing with minus 1.53, for instance. I'll be reading minus 1.5 under 0.03. So I'll be looking at the value here. So, but in a case like this one, we're dealing with minus 1.5 alone. We're not dealing with any other thing after minus 1.5. So I'm just going to be reading minus 1.5 under 0.00. All right, under 0.00. So now, guys, go into your table now and go and read what is the value of minus 1.5 using your negative normal curve. Your negative table now. Go and read minus 1.5 under 0.00. I'm sure you guys are going to see that the value for your table there was 0.0668. This is the value under minus 1. This is the value you're going to get when you read minus 1.5 under 0.00. Thank you very much. So 0.0668. This is what you're going to get out of that place. Now, let me interpret that result for you. The meaning of this is that I told you guys already that everything you see here inside this space represents area or probability, anyhow you want to say it. That means the area you have shaded here that has a Z value of minus 1.5, the area was 0. This whole area I shaded now is 0.066. 0.068. That's just the meaning of that. That minus 1.5 has an area of minus 0.0668. This area we shaded, probability of Z less than minus 1.5 is equals to, another way, I told you, if you're talking of area, this is the area, 0. That means out of the whole one area, we said the area under the curve is total, the total is 1. Out of that 1, the probability of the Z being less than minus 1.5 occupies an area of 0.0668. All right. So we can say, somebody is asking why is it under 0.0? It's under 0.00 because, as I said already, minus 1.5 doesn't have any other value after it. So it's just, if it was minus 1.51, it's like saying minus 1.5 plus 0.00. Of course, that's minus 1.50, which is still minus 1.5. But if you had minus 1.51, you'll be reading minus 1.5 under 0.01. So you will not be using 0.00 there. If your question was minus 1.51, you'll be reading under 0.01. If your question said 1.52, you'll be reading under 0.02. If your question said minus 1.53, you'll be reading minus 1.5 under 0.03. If your question said minus 1.54, you'll be reading minus 1.5 under 0.04. It's just that pattern. You will see that the values for this column, this particular row, stretched up to 0.09. So you can find values for 1.51, 1.52 up until 1.59. All right. And the next thing after 1.5 now will be 1.6. So if you wanted to find 1.6, there's another place for 1.6 there. So that's just the way it works. So it's very simple. So the meaning of this now is that the probability, the interpretation of this now, if you are asked to find the probability of Z less than minus 1.5, all right, you're asked to find probability of Z less than minus 1.5. You go on to draw your curve. You identified the inequality. You know that this is where less than was. All right, you're done with that. You now went to your table. I told you that it's the table. Every value you have here is identified with the area under the curve, and also probability, anyhow you want to say it. So the answer to this question now, where they said we should find probability of Z less than minus 1.5, is actually equals to 0.0668. All right, good. So without wasting time, I want us to attend the next one. The next one now was probability of Z less than minus 2.3. This is also very simple. All you need to do is to first of all go on to draw your curve. Let me use this point here. Let me use this place to draw the curve. So if I want to draw the curve for minus 2.3, the first thing I want to go on to do is have my 0 as the center, obviously. Then I look at the values here, I can see minus 2.3. This is minus 2.3. So I'm going to put minus 2.3. Let's say this is 1, 2. I'm going to put it, let's say, around here. I'm going to say this is minus 2.3. That's what I'm going to say. Right? So I want to draw this out here. Now, I looked at my inequality sign. I can see we have less than there. Less than. That's less than. So obviously, I'm coming on to shade the less than part. That's this part. Good. Again, let me repeat this again. Your table doesn't read from right to left. So imagine we were to shade this other part. Your table cannot give you values from here to here. Your table will only give you value from left to right. Now, in this case now, it looks very nice that what we're looking for is actually from left to right. You can see from left to right is what we're looking for. So our table will give us the exact value we're looking for here. So this is a good a scenario where we don't have to sweat it. We just have to go to our table. We get our result once, because what we are shading is from left to right. You can see what I mean by left to right means. You can see this shading is happening. If I shaded and I'm shading everything this way, my table is fine, if that's the part I'm looking for. But once you start looking for a part that is from left, right to left, let me give you some scenarios like that. Let's say I'm dealing with this. Let's say this is minus 0.5, for instance, and I'm asked to find probability of Z greater than minus 0.5. But for this is 0.5, and I'm dealing with greater than. Of course, I'm shading this place. Now, in this scenario now, this is the place, the shaded part is the place I'm interested in the area. I cannot go on now and say, I want to go to my table and go and check this value, and then I'm going to get the area here. No, I will tell you what you're going to do in cases like this. What your table will give you, if you check your table using this value, will be from left to right. Now, this area it will give you, see, this is the area your table will give you. If you check it like this is the area it will give you. It doesn't give area from right to left, it gives area from left to right. So now this side it will give you. So if you go on to go and fix the answer as your result, you'll be wrong, because your table, every part of your table is always from left to right. You can see how they drew the diagram. They drew it shading, they shaded from left to right. You see this one shaded from left to right. That shading is what your result is, what your values in the tables are for. They are not meant for anything right to left. So your table cannot produce the direct answer for this region now. It cannot. Your table cannot do that. So once you have a shading that is from right to left, you cannot go and just go and say, I want to pick this from my table. It won't work that way. Your table only produces values from left to right. So now, we have gotten this now. We've gotten our diagram, right, for this second question of minus 2.3. Good. Now, what do you want to do? You go to your negative table. Again, you can see this is a negative Z value. So you don't pick your positive Z value in this case. You pick your negative Z value. You go and pick that. And what do? You go under, this is minus 2.3, exactly 2.3. There is no other thing after 3. So what you just want to do now is to say, let me go now to my Z value, because don't forget, I told you guys, this is your Z value here. This is your Z value. So you go under the Z column, you go and look for minus 2.3 is there. You look for a minus 2.3 there. It will be somewhere maybe here. You will see it there, minus 2.3. After you see that on your table, now, the question is, what are you going to be looking for? Under what will you pick your values from? Now, if this was minus 2.34 now, you would have gone to look for minus 2.3 under 0.04. You would have gone to look for minus 2.3 under 0.04. If it was minus 2.33, you'll be looking for minus 2.3 under 0.03. If it was minus 2.32, you will look for minus 2.3 under 0.02. Now, but in this case, it was just 2.3. Nothing was attached to it. So obviously, you know that 2.3 is the same thing as 2.30. So you're looking for 2.3, minus 2.3 under 0.00. So you go to your table now to find what was the value that you see when you check minus 2.3 under 0.00. So you can go on now to check that quickly, guys. Go on to check that quickly. Minus 2.3 under 0.00. Can anybody give me the answer? Minus 2.3 under 0.00. Can you tell me what that answer is? Guys, we're using the standard normal probabilities for negative Z table. So can you check minus 2.3 now under 0.00? What do you get, guys? Minus 2.3 under 0.00. So if you look at minus 2.3 under 0.00, you will see 0.0107. That's what you're going to see. Minus 2.3 under 0.00 is 0.0107. Now, that is my answer for this, because I told you that answer you got now, I told you that these things you have here represents the areas, or you say probabilities. So this area here where we shaded is this area now. The meaning of that is that this area is 0.0107. That means we said this whole curve, the total area under the curve is 1. We are now saying that the area that represents Z less than minus 2.3, that area is that part where Z being less than minus 2.3 has an area of 0.0107. That's just the meaning of that. So we can go on now to write this as the probability as 0.0107. So sweet and beautiful. It's that simple. Of course, I understand that you guys, you need to be patient with yourself. When you're learning something new, just calm down, try and focus. That's why we have several questions we're going to be dissolving so that you get very we're not hasty or trying to rush. We want to take things. So if you don't get it the first time, you get the second one. If you don't get it the second time, you get the third one. Before we're done with the O5, you are done with it. You are sound in knowledge. Now, before I give you guys the opportunity to solve this yourself, of course, we're still going to do it here. I want to now explain to you a different thing now, because I don't want to rub these two things. This was the diagram that I drew for the first one. This was the diagram I drew for the second one. So for the first one, we were told to find probability of z less than minus 1.5. Of course, as usual, we went on to produce our curve. We identified minus 1.5. We shaded the region of interest. Then we went on to check our table, of which I told you that your tables read from left to right. But luckily for us, our area of interest was from left to right. So that was why we were able to just say, oh, good. Since it was left to right, we went into our table, fished out the answer. Of course, if you check minus 1.5 on your Z table, under 0.00, that area that it produced, 0.0668, represents the area we're looking for. Now, but this is the question now. Let me assume I'm solving the same question now, but a different style. Let's say I'm asked to find probability of Z greater than minus 1.5. If I'm interested in finding this question now, this is one thing that will happen. Now, the diagram is still going to be the same thing, only for one thing. We have the same diagram, obviously, as I said already, but this is going to be different in the sense that our shading will be different. If this was minus 1.5, of course, that's the first thing we're going to do. We identify this place, we roll it up. Now, but now we're interested in greater than minus 1.5, not less than. Less than was what produced this shading. Greater than will obviously be like this. That means the other side, this other side that we did not shade here, is where we're going to be shading for greater than. So obviously you can see that we're dealing with a different scenario. And I told you guys already that your table will never give you an answer from right to left. So you can never get this area under any curve perfectly. You cannot say, I got into the table and I got this. No, it doesn't work that way. So what do you do in cases like this? Guys, I'm sure many of you there already know the answer. The total area under a curve is 1. So, and your table only gives you from left to right. So whatever you are dealing with, when you're trying to find the other side that it cannot give you, just go on to use your understanding that the total area under the curve is 1. So guys, let me ask you, if this whole area, the whole area of this curve is 1, and this place is 0.0668, what's going to be this other place that we have not shaded? Can anybody tell me the answer there? The whole area under the curve is 1. This place that we have shaded is 0.0668. What's going to be the other area we have not shaded? If the other area is 1. Of course, it's going to be 1 minus 0.0668, because the whole area is 1. If this place we have shaded is 0.0668, that means the other part will be 1 minus that. So obviously, what you do in a case like this, when you're having greater than, like in a case like this, that's why I've taught you how to draw the diagram, where you notice like the place you are shading represents right to left. And you know you cannot read this directly from any table. So the value you will get, what you have to do first is the value you will get as minus 1.5 in your table will be representing this other place, this place. And this place it will represent. You'll be getting this place from the table. If you check this one, if you're given this question now, what you will find for minus 1.5 in your table will be giving you this place. You won't have this other side you are interested in. So after getting this place, all you have to do is just say 1 minus whatever you got here. Then that will be your answer. That's the trick to it. All right. So in a case like this now, if you're trying to find, if you're going to find probability of z greater than 1 minus 1.5, you will just say 1 minus the probability of the one you have found for the other. That will be 0.0668. Whatever answer you get there will be your answer. Very simple. So let's do this other one also. We are dealing with probability of z less than minus 2.3. We shaded this part. But the question is, what if we are giving another question where we are dealing with z greater than minus 2.3? Of course, in that case now, you see that our diagram is different. If this is 2.3, let's call this 2.3. This is, minus 2.3, This is minus 2.3. Greater than, because of this greater than now, our place of interest will be, area of interest will be this place, which is not going to be ever possible to get this on a table. Your table will never give you a value from right to left. You can see extreme right to a part in the left, it doesn't produce values like this. It only produces values from the left, the extreme left, up until somewhere on the right, like all these cases. So what you're going to do in this case now is that you have to go on now to first find for minus 2.3. So this other part now if you're getting this place as 0.0107, of course, this other place you are shading now will be 1 minus 0.0107. The value you get here now will be your answer for the greater than minus 2.3. That's the way you solve these things. All right. So guys, now that you understand that, I want you to start with this. Can you go on now to solve the probability of z less than minus 3.38? And then subsequently, I want you to do for z greater than minus 3.38. Can you do that very quickly? Of course, I'm going to do it for you, but I want you to do yours first. So the task ahead of you now is to solve for probability of z less than minus 3.8. So of course I can rub this one up now. I'm going to be doing it, of course, here. I would love you to make your attempt also. For somebody asking about if you have a value in 3 decimal places, what you have to do when you're using this table is just to, of course, estimate, approximate up to 2 decimal places, because your table only works for 2 decimal place values. So in the case where we have, let's see how we do this one. Of course, the diagram, you have your diagram, you deal with minus 3.38. So if this is 0, minus 3, let's say minus 3 will be somewhere here. So let's say this is minus 3.38. So less than, of course, minus 3.3, we can put it somewhere here. I'm sure you guys don't argue with that. So we draw our values here. Since we're dealing with less than, of course, our point of interest is going to be this. All right, that's our point of interest. Now, since this is from left to right, this is very readable with our table. So what you have to do is to go on to look for, what you're going to be doing now is you'll be looking on your Z column minus 3.3, all right? But you'll be looking for it under 0.08. Of course, that gives you minus 3.38. So you go on to check your minus 3.3 under 0.08. So if you check your minus, minus, let's go on now to check the table. I want to open my home table right here. Minus 3.3 now, I can see that. I can see minus 3.3. So I go under 0.08. 0.08 gives me a value of 0.0004. That's what I got from my own table. And I believe it's the same thing you are also going to get. This is what I got as your value for this. So that means the area covered by this probability, the area where Z is less than minus 3.3, has an area of 0.0004. All right. So I told you to go on to find subsequently for Z greater than minus 3.38. That means in that case, now I'm asking you to find this other area greater than minus. So all you need to do for that question would have been for you to just solve. So this answer, the answer to this is 0.0004, right? Then if you are told to find probability of Z greater than minus 3.38, of course, in that case now, your area of interest will be this whole place here. So in that case, you have to do 1 minus whatever you got as this other one, 0.0004, right? That's how you do that. Now, that's very nice. Thank you. I can see you guys are getting the answer. So let's go to the next one. That's probability of Z less than minus 2.14. You guys have started confusing yourself. Just follow what I'm telling you, all right? That person asking about using positive table, don't confuse yourself. That's the road. That's a very clear road. What you just wrote there, that person, that's a clear road to confusion. And I'm not a big fan of course, there are many things that we can do and use tricks and everything. But when we are trying to give, clarity, we, of course, we rather take things in a way that everybody can really flow with it. All right. Now, we have this other one, minus 2.14. Of course, I want to draw my diagram first. And minus 2.14, I can put that around here. Minus 2.14. Of course, here. This is, and okay, 14. I did not write well. 14, not just 4. So, of course, dealing with minus 2.14, I'm looking at my sign here. My sign is less than. So, obviously, the shading will be done in this region, because this is less than, obviously. All right. So if I'm shading that part now, of course, I can now go on to check my table, because I can see clearly where that the area I'm shading represents what I'm looking for. My table gives me left to right, so I don't need to bother now. I can just go on to my table, and I'll be looking at minus 2.1 under 0.04, because that gives me minus 2.14. So when I go to my table, I want to do for minus 2.1. So you go under minus 2.1. You go under minus 2.1. Of course, I can see that. Then on that 4. Now, you guys, I need to tell you, you need to be very careful. Of course, you can see the possibility of you missing values, especially if you are in an example. So try and be very careful the way you trace them out so you don't make mistakes. Minus 2.1 under 0.04. I can see right there, I'm getting a value of 0.0162. This is the value I can read out from my table, 0.0162. Is that the value you guys got? So that means the meaning of that value you just read is that, because as I need you guys to really understand the interpretation. That means all you are saying now is that this shaded area has an area of 0.0162. That's the meaning. That's what your table does. It gives you area under the curve. All right. And also, you can also see it as giving you probabilities. Anyhow you want to say that. Probabilities and area, I already gave you guys some when we started this class, the relationship between them. They are the same thing. You know how to, if I say probability of the whole thing is 1, all right? Probability, and then the area under the curve is 1. So understand how to use the relationship. So the probability of Z less than minus 2.14, we see it as 0.0162. That's just It's very simple and straightforward. That's how simple this work is. It's the major key is knowing how to read your table. So once you know how to standardize, because don't forget, guys, you're not really giving in many cases standard values like this. You're going to be giving the hex values. So you need to be able to standardize to this form. So once you're done standardizing to this form and you have the Z values now, then you have to go read your table to give the final answer, which is the probability. Very simple using your table. So now imagine you were told to find probability of Z greater than in this case now.